Welcome to section 3, and in this section we're going to continue our work on our walking skeleton and complete our end-to-end functionality so that we have both our API and our client prepared for when we build the rest of this application. So let's take a look at what's coming up in this section. As I mentioned, we're going to complete the walking skeleton, and hopefully by the end of this you'll have an introductory understanding of using the Angular command line interface. Just like the .NET CLI, we have an Angular CLI, and it does the same kind of thing. It allows us to run our application and create a new Angular application. And we'll also be doing that as part of this section. We're also going to review the Angular project files. Just like the .NET CLI, it gives us a template to work with. The Angular CLI does the same thing, and we'll take a look at the project files that we're given and how Angular bootstraps the application and displays the results in the client browser. Now, because we've got our API set up, we're going to need to make an HTTP request to our API, and to do that we're going to make use of the Angular HTTP client service to allow us to go and fetch the data from our API. And what we're also going to do as part of this is we're going to get our development environment as close to as possible as it's going to be in production. And that means running our Angular application over the HTTPS protocol. So we're going to need some certificates, which is no big deal. It's pretty easy to do, and we're going to get our browser to trust those certificates. What we'll also do is add some additional packages. Particularly in this section, we're going to add the styling framework we're going to use, which is Bootstrap, as well as some icons from Font Awesome. So that's what's coming up in this section. So in this lesson, we're going to take a look at installing Angular and creating our Angular projects. But before we do, I just want to talk about Angular versioning, as this lesson has been updated in 2021, November 2021, as Angular 13 has just been released. And one of the most common issues that students have faced when taking this course is attempting to use the very latest version of Angular and then running into issues, because not so much the code changes in between versions, and the code that we're writing here was recorded on Angular version 10, and that code is perfectly valid in Angular 12 version 13, and everything works fine for the Angular side of things. But where we run into problems is when we're installing third-party packages. A bit later on, for example, we're going to want to install Bootstrap, and one of the packages we install is called NGX Bootstrap, but it takes them a few months to catch up with a major release of Angular. So it can cause issues with third-party packages. And if we take a look at the Angular versioning and releases, if we take a look at their release frequency, then we can expect to see a major release every 6 months. Now, this comes from Google, and the Angular team have to meet this schedule even if they do not have anything major to say between major releases. I'm not quite sure what the reasoning is behind this kind of forced policy where there has to be a major release every 6 months. But my guess is that they're trying to catch up with the version numbers of React, which is currently on version 17. And React does not update every 6 months. It's more of a, when they have something major to say, then they'll create a major release for React. But Angular, every 6 months without fail, they seem to be updating Angular version number with a major version. Now, for that reason, and because it does cause an issue with third-party packages that have not had a chance to catch up with Angular's release cycle, we're going to make use of Angular version 12. That is the version I've tested it with. It's the prior version to as at November 2021. The current version is Angular 13. And if you want to avoid issues on this course and make sure that things work as expected, then I'm going to show you how we can create our project using Angular 12 and help you avoid any issues. This is setting us up for success rather than failure. Also, what you'll need installed is Node.js, and we need greater than 16.10 for Angular. Currently, the latest stable version, or the long-term support version, is 16.13.0. If you download and install, as long as your version of Node is greater than 16.10, then we're good to go. So over in the command prompt or the terminal, then we can now go ahead and create our Angular application. First of all, just going to run a quick check to see which version of Node I'm on, and I'm on version 16.13.0. As long as it's greater than version 16.10, we should be okay. And we want to ensure that we're using Angular 12. So one way we can do that is to run npm install, and we're going to install the Angular CLI globally. And we can say npm install -g at Angular /CLI at 12. And this is going to get the latest version of Angular version 12. And as mentioned before, this is the one that we're going to want to install into our computer. So we'll go ahead and install this. And we always get some kind of warnings whenever we're installing these kind of packages. Please ignore them. They don't do us any harm. And if it's a warning, we're okay to continue. If it's an error, then we have a problem that needs investigating. And if I just type in ng --version, then we get to see which version of Angular CLI we're on and which one we're going to be using. And we're using version 12 across the board there. And it gives us a warning saying that the current version of Node is not supported by Angular, which is not quite true because it is supported by Angular. So again, it's just another warning, and I'm going to ignore that and say clear. Not entirely sure why that warning is showing up actually, because in the documentation, it's definitely 16.10, which is the minimum. And as long as we're greater, then we should be okay. But let's give it a go. And in order to create our new project, we're going to say ng new, and we're going to give it a name of client. And there's a flag that we need to turn off, and the flag is strict. And we need to set this to false. And the reason for doing so is that when I originally wrote the code, it was on version 10 of Angular, and strict mode was not a thing at the time. So the code was written without strict mode in mind. Please don't worry about that. It's not a problem. But if you do leave strict mode on, then you will run into some warnings and errors which will block you from continuing, because your application, if you enable strict mode, will expect strict mode's type of code, whereas the original code was not written with that in mind. So we're going to say strict false for this and press return, and then we get to answer some questions. And the first question is, would we like to enable Angular routing? And we are going to need routing in our application, so we're going to say yes. And then it asks us, which style sheet format would you like to use? And we're going to keep things nice and simple and just go for CSS in this case. Now it's going to go ahead and create our Angular application, and I'll pause the video because this will take a minute or two to create it and come back after it's completed. And this is what you should be seeing after that's been created successfully. So let's go and take a look at this inside VS Code. And what you might see is a pop-up that just disappeared off my screen there, asking or warning you that some features in Angular services are not available if we do not enable strict templates. Don't worry about that. If we go to our extensions and take a look at the extension settings for Angular language services, then this is the prompt that it's referring to, and it says prompt to enable the strict templates flag in Angular compiler options. And note that strict mode is only available when using Ivy. We're going to turn that particular flag off. It's not helpful, and because we're not using strict mode, then it's going to flag, but it doesn't cause us any problems. What you might see, and this is really outside of control of what I'm demonstrating, is sometimes you might see myself being able to import things automatically that doesn't work for yourselves. Now, VS Code has been updated several times. The Angular language service has been updated several times since I recorded the demonstrations on this course. So I can't promise you the exact same experience when using the Angular language services and automatic importation. If you are running into problems with Angular at all, then one thing to try, and it may give it a kick and it may enable the automatic imports, is just go into the command palette and use the developer reload window and see if that resolves any particular problems you have. But now we've got our client application inside here. We can see all of the different files and folders that we have inside there. What we'll take a look at next is how we can run our project, and we'll take a look at what these files are inside our new Angular project here. So we've now got a shiny new Angular application called Client in my case, and we've got all of these files that were created for us by the Angular CLI. Now we'll take a look at a few of the important ones very shortly, but first of all, let's go and make sure that our application is actually working. So what I'm going to do, I'm just opened up a new terminal session. I'm just going to cd into the client folder, and then I'm going to run a command called ngserve, and this is going to start our Angular development server. It's also going to compile our TypeScript files contained inside this application into JavaScript and serve those JavaScript files from memory. And once this is started, it tells us that the Angular Live development server is listening on localhost 4200, and if we take a look at what else is going on in here, it tells us what JavaScript files have been created. And these are not physical files, these just reside in memory. So let's go and take a look at the browser to see what we can see. And what I'll do, I'm just going to say localhost 4200 and HTTP localhost 4200, and we can see the Angular app is running. And this is just the default Angular template page. Sometimes it changes when they release a new version of Angular, but this is the one for Angular 10. So what we'll do is we'll take a look in VS Code and see what is responsible for displaying that on our page. Now what we have with Angular is a single page application, and our single page is this index.html file. Pretty normal. And we have a title in here, which is the name of what we created, and we can change this to the name of what we are creating, which is a dating app, and this will be reflected in the Chrome browser tab. And then we have the body of our HTML. Now the only interesting thing inside here is this app root, and this is an Angular component that's going to be loaded into the body of our index.html when our app is running. But we don't see any JavaScript tags inside here. But if we go across and take a look at our browser again, we right click and we inspect, then we can see in the page we do have the 5 JavaScript files that were created when we compiled and ran our application. Now something happens behind the scenes when Angular runs our application. These JavaScript file references get injected into our index.html page by a utility that Angular uses to build our application. That utility is called Webpack. We don't need to worry about it. Angular does this itself as part of the command line interface and when we run our application. So let's go back and take a look at what's responsible for actually bootstrapping our application. Now this app root is our app root component, and if we take a look inside the app folder, then we can see our Angular files inside here. Now the app component.ts, this is our app root component. We have a class called app component. It has a class property, just the title equals client, and we have something here known as a decorator. Now TypeScript supports decorators, and this is a way of giving a normal class some extra powers, and in this case it's giving our class the ability to be an Angular component. So this provides some configuration metadata that determines how the component should be processed, instantiated, and used at runtime. Now Angular works with the concept of components, and components are the most basic UI building block of an Angular app. When we build our Angular app, we're going to be creating lots of components that are going to build the user interface that our clients will see. So most of our work is going to be done in components, which are going to provide the data for the view inside the browser. What we also have inside here is each component, as well as the selector, has a template URL and some style URLs. Now we can create the template URL, the HTML, inside the component if we want to, but it's kind of messy, and Angular, when we create our Angular components, will always create separate files for the HTML and the CSS. And if we go and take a look at our file system and take a look at the app component HTML, well, we can see what we have here is quite a big HTML file. Now this is making up all of the content of the page that we saw in our browser, and we don't need any of it. So what we're going to do is say Control A and delete. And what we'll do is we'll just replace it with an h1 tag saying dating app. And if we go across and take a look at our browser, we'll see this reflected in our page. Angular is going to automatically reload our browser page when we make a change inside our app. It's going to recompile things and it's going to display the latest content rendered on our page. So what we can also do with Angular components is we can pass data from our component to our view, the template itself. And the way that we do this is with interpolation. So if I wanted to change the title, and in fact let's just call it the dating app, and then we can go ahead and use this property inside our template file. And this is known as interpolation. And what we do here is we just provide this with curly braces, 2 of them, and we can swap dating app there for title. Now it gets this property from the class property inside our app component, and if we go and take a look at our browser, we can see that this has updated to the new title there. Cool. So we can get data from our component into our template, and I guess you would be expecting that, otherwise what's the point of using Angular for anything? So what we do want to know is, how does this component get bootstrapped? How is Angular providing this component content to our index.html page? Obviously our browser doesn't know what this is, and it needs some help because it's going to get this from our JavaScript files. So let's take a look inside our project contents, and every Angular application has to have at least one module. And in our case, we've got a root module, that's our app_module.ts file. And inside here, we have a decorator to tell Angular that this is a module, an Angular module. And our Angular module declares the components that are available inside our application, and they go in this declarations array. We can also import other Angular modules into other modules and make use of them in our application. So in this case, we have a browser module. We're creating a single page application, and we need the browser module so that our code can be added or displayed in our browser. We've also got the app routing module, which we'll take a look at a bit later when we're discussing routing. What we have then is a further element to bootstrap any components when our application loads. And what goes in this array is the set of components that are bootstrapped when this module itself is bootstrapped. And we're bootstrapping our app component, and that's the one that we added or we see in our index.html file. So let's go and take a look at what bootstraps the bootstrapper. And we have another file in our Angular project, and this one's called main.ts. And what we have inside here is Platform Browser Dynamic, which is responsible for providing the code to bootstrap our app module. And once our app module is bootstrapped, it then bootstraps our app component, and our app component is declared as a selector inside our index.html, and that's why we see the result that we're seeing. Now, a couple of other files to point out that we'll come across as we build our Angular application. I'm not going to go into much detail at this stage because it'll be pretty boring. But because we're developing a TypeScript application, we need a tsconfig file that gives TypeScript its configuration. And one thing to point out here is one of these settings is to enable experimental decorators. That's how we're able to use decorators inside our Angular classes or our TypeScript classes. Decorators are not currently supported in JavaScript yet. It's possible to use them in JavaScript because there's many ways to use modern JavaScript and get it compiled into something a browser will understand. And in TypeScript, we enable this functionality via our tsconfig file. Also, we have a target inside here. What's our code going to be compiled to? And in this case, it's going to be compiled into the ES 2015 version of JavaScript. Now, this is only supported by modern browsers. And in the case that an older browser is attempting to access our application, Angular will recognize this, and it will give the browser an older version of JavaScript. It will be a bit bigger because it's older, but at least the browser will understand it. And another file that we'll come across every now and again is this angular.json. This provides our Angular CLI some configuration, and if we want to add some extra scripts or some styles into our app, then we'll come back here and do that. But we'll see all of this as we build our application. For the initial part of this course, we're going to focus on the building blocks of any Angular application and that's going to be our Angular components. So what we'll take a look at next is a very specific lesson for those of you using VS Code, because we do need to give VS Code a bit of extension support so that we could use Angular efficiently within it. So if you're not using VS Code, please skip the next lesson. But if you are using VS Code, then we're going to take a look at some extensions. So in this lesson, what we're going to do is we're going to take a look at VS Code extensions that help us build an Angular application in Visual Studio Code. Now, when it comes to building Angular applications, it is possible to do it in Visual Studio. It is possible to do it in Rider. And with Angular applications, there's significantly more choice about what you use to help build the application. Now, Visual Studio Code is excellent for Angular, so I'm going to stick with using that. And it's just a convenience thing to use the same code editor and have both projects in the same folder when working on both the .NET and the Angular application. Now, if you're not using VS Code and you have no intention to use VS Code, then please go ahead and skip this particular lesson. For those of you that are, then I'm just going to go through some useful extensions that we need to help us develop this. Now, the first one we need is something called the Angular Language Service, and we'll go ahead and install this one. And what this one gives us is very similar to the C# extension for .NET. It gives us things like completions lists, diagnostic messages, quick information about what we're looking at inside our code, and also go to definition. So we'll go ahead and install this into our application. What's also helpful, and it's not compulsory, you may prefer to type it all out by hand, but I'm just going to search for Angular snippets, and the top one here by John Papa, the Angular 9 version of this, it'll just help us type some common Angular things that we need in our code relatively quickly. We're not going to use it for big things, just little things that help us type our code more quickly. So we'll add that as well. And another very useful extension is called bracket pair colorizer. And I'm just going to go ahead and install the updated version of this bracket pair colorizer 2 and add this to the application. If we take a look at the screenshot here, it's pretty clear what it does. It gives each opening and closing bracket a different color so that we can see which are nested tags very easily or nested sets of brackets inside our code. And it's a very nice extension to install. So if we go and take a look at our app component, we can see the difference this makes. We can see the different colored brackets for the outer and the inner ones. And because we've installed the Angular Language Service now, when we hover over the title, then it recognizes that this is a property of the app component and it's a type of string. So we get additional information about what's going on with our components thanks to the Angular service. So for Angular, this is all the extensions we need and we're good to go. So what we're going to take a look at in this lesson is making an HTTP request from our Angular component and fetching the data from our API. But we need some help to do this, and what we need is to go to our app module and we need to add a module from Angular to help us do this. Now what we're going to add here is the HTTP client module, and at this stage we don't get any help with importing this from VS Code, unfortunately. So on this occasion we need to go up to the top and we need to import manually the HTTP client module from @Angular common /HTTP. And now our HTTP client module is ready for us to actually use in our application. So what we're going to do is we'll use our app component to go and fetch the data and then display it on the page, because this one has already been created for us. Now Angular uses dependency injection just like we used it in .NET Core. And the way that we use dependency injection in Angular is to use the constructor injection, just as we did in our .NET application. Now what we do in this case is we declare the thing that we're about to inject as a private or a public variable. So we're going to give this one a name of HTTP, and then we specify a colon and we use the HTTP client. And this is the one that we want, this HTTP client. We do get auto import assistance from VS Code from this point onwards. And we get a description about what this does. It performs HTTP requests, and it tells us that this service is available as an injectable class with methods to perform HTTP requests. This sounds exactly what we're looking for. So let's bring this in, and we need to close off the constructor with curly brackets. So when we make an HTTP request to an API, this naturally is an asynchronous request. It's going to take some time to go out wherever the API is to go and fetch the data and then bring it back to us. And there's a good place to do this inside an Angular component, but it's not the constructor. This is normally considered too early to make an HTTP request. We want to construct the component first of all and make sure that we've got the HTTP service available. You could do it in the constructor, it would still work, but it's considered too early. Angular comes with lifecycle events. The lifecycle event that takes place after the constructor is known as the initialization. So what we can do in order to use that lifecycle event, what we need to do is say that the app component implements the onInit. And once again, we get assistance for this from VS Code. And what this is a lifecycle hook that is called after Angular has initialized all data-bound properties of a directive. And basically, it just comes after the constructor. And when we implement this, we get a red squiggle to tell us that we've got an error. Whenever you see an error, you want to get your mouse and put it over the error so that we can see what it's telling us. And it tells us the app component incorrectly implements interface onInit. Now, when we implement when we add an interface, it might have some required properties or required methods. And the onInit interface has a required method that we need to implement. So what we can do is put our cursor inside the error, use the quick fix, and then say implement interface onInit, and then it goes ahead and creates the method for us. Now, during the course of this lesson, in order to go and get the data, bring it back, display it in our client, I'm going to be very brief and not explain in detail everything that's going on. We will come to that, I promise you. But for now, our main goal is to just go and get some data. In other words, there's a couple of big concepts here. One of them is TypeScript, and the other one is what we get back from our HTTP request. Now, in the case of TypeScript, TypeScript gives us type safety, unless we use this particular keyword, which is any. We're saying that our users are a type of just about anything you can imagine. This could be a string, it could be a number, it could be a date, it could be an array of dates, it can be anything. When we use this any keyword, we're effectively turning off type safety in TypeScript. We get no type safety with our users property here. We will talk about TypeScript, and we will be introducing type safety because it's brilliant and it stops us from making silly mistakes. But for now, just so that we can move forward, we're just going to use this any type for our users property. And what we'll also do is we'll just remove this void. This tells our method what it's going to be returning, and it tells us that our ngOnInit method doesn't actually return anything. What I will mention about TypeScript is that it's very good at inferring what type of thing we're going to be returning. And if I hover over the ngOnInit, even though I've removed void, it knows that because of the code inside the method, it's not actually returning anything from this. So let's make use of our HTTP service. So what we do when we want to use our service, we have to use the list keyword when we want to access any property inside a class. HTTP belongs to list class. Title belongs to list class. And in order to access any of those properties, we need to use lists to gain access to them. So we're going to be using the HTTP service to make our request. And if we add a period, then we see all of the different methods available for us to use inside this service. And because we're going to get our users, we're going to be using the HTTP get method. Now, if we take our mouse and hover over the get, then we can see what our get method expects as parameters. And what it wants is the URL of where it's going to get whatever it is we're getting as a string. And then it can also take some options, but all of the options, wherever we see this question mark, this means that these things are optional. We do not have to provide them. And then if we scroll further down, we see what the method actually returns. And this returns something called an observable. Now we're dealing with asynchronous code here, and the way that Angular handles asynchronous code is to use observables. These are not yet a feature of JavaScript, but they are available in TypeScript. And these are really cool, but we're not going to discuss them in detail right now. We're simply going to use them to go and get our data from the server. But one thing it does say, that it returns an observable of the response with the response body as an array buffer. Effectively what this means is that the response body, we know that our users are going to come down as in the body of the response from the API server. We saw that in Postman, and that means our users are going to be available as soon as we've got the data back. So let's add the first part, and we know that this is the URL of our API server, so we'll need to add this as a string. And spelling is essential here. It's a string and we get no type safety on strings. So I'm going to add the address of our API and our users because this is what we want to return from this. Any deviation from this exact spelling that you see here, unless you've called your controller something different or you didn't add API, then it needs to match exactly what our endpoint is. Otherwise, you won't get anything back, or you'll get an error. Now, one thing that I will mention about observables at this point is they're lazy. They don't do anything unless somebody subscribes to them. And in order to get the data and get this method to do something, we have to use the subscribe to go and get our data. Now, in the subscribe, if we take a look at this tells us what we can do after our subscription has taken place. And observables can be streams of data, but not in the case of an HTTP request going to an API. But what we'll find is that we get our data back in the next part of this request. If the response is anything but a 200 OK response, then we're going to move into the error parts of these parameters. And whatever happens, this request will complete because it's an HTTP request. Now, all of these parameters are functions. We tell our subscribe method what we want to do next, what to do in the case of an error, and what to do on complete. We don't need to provide all of these options. We can simply leave it blank, but we do want to do something with the data when it comes back to us. So what we'll do is we'll say that we know we're going to get a response back. So we'll say response, and this is the parameter, because what we're going to use inside here is referred to as an arrow function. It's called an arrow function because the equals and forward angle bracket looks like an arrow. And this response is going to contain the users from our API. So what we can do is we can set our users class property here to the response that we get back from our API server. So what we'll do is we'll say that list.users equals response. And what we'll also do is we'll handle the next part. So after the closing curly bracket, we'll specify error. And once again, we need to give this a function as well. So once again, we'll use an arrow function, and we'll simply log out any error to the console by saying console.log and then the error. Now, there is a third part to this that I did mention, and we could do something when it completes, but we're not going to do anything with that because after we've got the response, then this is going to complete anyway. So what I normally like to do is not add the method inside the ng-on-init, but rather use a separate method, and I'm going to say get users and then cut and paste this code inside the get users method like so, and then inside the ng-on-init we call the get users method. Now what we can do is go and take a look and see what's happened, because we know that our app component is going to be bootstrapped when we load our application, and when this component is initialized, this method is going to be called. And if we go and take a look at the browser, and we'll just refresh, then we can see our app. We're not actually doing anything to display the users, so we shouldn't see anything extra there. But what we can see in our console is we've got 2 errors. Let's go and take a look at what those are. Now, when it comes to troubleshooting errors, you always want to open up the console and take a look at what's going on inside there, because you want to get as much information as possible about any error you encounter. It gives you the best chance at resolving it. And what we can see here is that we've got an HTTP request going to the address of our API from origin, and this is the address we're running our Angular application on, has been blocked by CORS policy. And it tells us that no access control origin header is present on the requested resource. And what we also get is the part that we logged out to the console. Because this was not a 200 success request, what we actually did was we went into the error part of our subscribe, and if we take a look at line 23 in the app component, then we can see that that is what we're logging out. We didn't go into the next, this didn't work, but we did go into the error and we logged out the HTTP response into our browser. And if we expand this, then we get more information about the response that's come back from the server. But we've got a problem, and it's something that we can fix, but we have to fix this on the API. So what we'll take a look at next is implementing CORS in the API. Okay, so we've encountered our first major problem, and it's not really a problem, it's something that we would expect, because CORS is a security mechanism, and CORS stands for Cross-Origin Resource Sharing. And this is effectively a security mechanism built into all modern web browsers, and it basically blocks all the HTTP requests from our front end to any API that is not in the same origin, and localhost running on port 4200 is not in the same origin as something running on localhost port 5001. So we effectively are not allowed to go and get resources from something that exists in a different origin unless that resource itself supplies a header saying that this is okay. So what we're going to do is we're going to go back to VS Code, and we need to do this inside our startup class. There's 2 parts to this. First of all, we need to add the service for CORS. So inside the configure services method, we're going to say add CORS into our application, and ordering doesn't really matter inside here. However, ordering is very important inside the configure method. And it's absolutely necessary to place the use CORS in a very specific place inside here. Now, the rule is it has to be in between the call to app use routing and the app use endpoints. But a bit later on, when we implement authentication, then it's also necessary to add it prior to the call to use authorization. So the right place to add this is just in between app use routing and app use authorization. And what we want to do is say use CORS inside here. Now this middleware can take some configuration, and what we can use inside here is an expression. And the way that we write the expressions is we give it a parameter name. This can be anything. I'm terrible for just using X for most things, but what X really is the policy that we're implementing here. And if I say x.period, then we get the different options that we can use with CORS. Now, a lot of developers would prefer to say what the parameter actually means and give it policy dot and then allow any header. But I can't promise you that I'm going to be using that all through this course. I do have a tendency to use X as the name of the parameter that we're using and then just chaining on the different options we need here. Now we want to allow any header, we want to allow any method, and what we want to do is say with origins, and then we can specify the origin of where we're going to allow this request to come from. And we know the address of our Angular application. It's http localhost colon 4200. And this is our CORS policy as it stands at the moment. We're okay with allowing any header. We are going to be sending up headers such as authentication headers to our API from our Angular application, we want to allow any method. We want to allow put requests, post requests, get requests, etc. But we are going to be specific on the origin that they come from and say, sure, you could do any of this, but only if you come from here. And what we should find if we go back to our browser, and let's go ahead and refresh the page, is now we don't see any errors. And if we go and take a look at our network request, what we can see inside our network request is the call to the user's endpoint on our API. And we can see in the preview area, we can see the response we're getting back here. And if we take a look at the headers, everything looks good. We get a status code of 200 OK. And we can see in our response headers now, we have this access control allow origin header, and that's the reason this request is now successful, whereas it wasn't successful before. So what we'll take a look at next is actually displaying the contents of this inside our user interface, and we'll take a look at that next.